Today I'm going to show you how I made this robot radio controlled and battery powered. Hi, I'm Trent. I've been working towards building a four-legged robot from scratch. In my last couple of videos, I showed off my cardboard prototype and I got it walking. Unfortunately, my first prototype design is horribly unbalanced. So the first thing I have to do is redesign it to make it lighter. Sadly, I didn't record myself actually doing this, but I pulled the whole thing apart, cut the body in half, chopped down the legs, and adjusted the servo positioning. The next thing I want to do is prototype my wireless communications. So I found some 915 megahertz radio transceivers on SparkFun. I went ahead and bought a few, but I should have looked into software libraries before doing that. So SparkFun actually links two libraries that are available for this module. The one from Low Power Lab requires the Arduino platform, and the Radiohead library is actually written in C++. So I'm not using the Arduino platform to build this robot. I am writing my code in C using the AVR C project and flashing the program to the chip using AVR. So my options are to port one of these libraries, or technically you can mix C and C++. However, it gets messy and I don't really want to go down that route. I found a library on GitHub that someone wrote for the ATmega64, and I was able to modify it enough to work with the ATmega328. It only required me changing some definitions for the differences in the pinouts. I also did have to change a few hard-coded values and clean up some of the code. I first built a proof of concept with 2 microcontrollers and 2 of the radios just to send and receive some data. One of the microcontrollers just sends 2 different values, and the other one receives those 2 different values and blinks an LED accordingly. It's kind of a lame proof of concept, but the next step is to add it to the robot. It wasn't too hard to actually wire the radio into the existing setup. I did have to rewrite my servo control code to use a different timer in the ATmega, and I also had to move 4 of the servos so that the radio could access the SPI interface. I test this setup with the radio powered up and the radio monitoring code running, but without actually using the radio yet, just to ensure I still have the existing functionality. I then wrote a simple program for a second microcontroller to relay UART commands over radio. For testing purposes, I do have to use my Raspberry Pi to connect to this microcontroller, since I'm using my USB to UART as a power source. I have a few bugs with my controller program. Reports that the command wasn't sent even when it was, and there's a little bit of a delay, but this setup is functional. The next step is to make this thing battery powered. The radio transceiver only takes 3.3 volts, and the servos need at least 5 volts for power. Fortunately, the ATmega can run at 3.3 volts, and the servos can take a 3.3 volt signal. For battery power, I have a clip that holds 4 AA batteries supplying 6 volts. I connect this to a buck converter to step the voltage down to 3.3 volts and plug this into the power rail on the breadboard, which supplies power to the ATmega and the radio. I then run 2 additional wires from the battery clip to the power rail, supplying 6 volts to the servos, which they can handle just fine. Time to really try this out. I am super pleased with how this project has been turning out so far. Obviously, there's still a lot that I need to do to make it more of a robot and less of a pile of wires and pieces. The body needs to be rebuilt. The cardboard just can't really take the weight, causing the robot to veer left and right and not walk straight, forward and backwards. I'd also like to make the circuit more compact, maybe using some perf board, maybe looking at a printed circuit board solution. And my kind of grandiose plan for this is to integrate a Raspberry Pi to play around with the robot operating system, or ROS, framework, so that I can add more complex robot stuff. Thank you all for watching. Your feedback, comments, tips, things to add to the robot to play around with would be great in the comments. I'm also new to the video editing. Obviously, this is my third video. So tips, feedback on that for the type of content that I need to be including with these kinds of videos, or even just kind of format, would be great to hear from you guys. If you guys thought this video was cool, leave a like.